Hi everyone, this is Santhosh Kumar. Welcome to MAXLOGICALS. First thing, all the viewers are subscribed to our channel, and today I will discuss one theorem on limits, that is fundamental theorem on limits. Let us discuss the what is the fundamental theorem on limits. If f and g are two real functions, we have f and g are two real functions with common domain. We have the common domain in f function and g function, then such that limit f of x, limit x tends to a, f of x equal to L, and limit x tends to a, g of x equal to m. Then we have to satisfy the six conditions, that is limit x tends to a, f of x plus g of x equal to L plus m. In mathematics we have four operations, that is addition or subtraction, and multiplication and division. These are all limit x tends to a, f of x and multiple of g of x equal to, the limit of f of x is L and the limit of f of g of x equal to m. Then both we are multiple the f of x and g of x, and the limits is also multiple. The functions are divided, that limits is also divided. Here we have one condition, that is g of x not equal to 0. We g of x not equal to 0. Here limit x tends to a, k multiple of f of x. Here k is any integer or any constant. The f of x that equal to k into f of k into L. Here limit x tends to a, g of x equal to k into g of x equal to k into m. We have the limit of the g of x is m and the k is any constant or any integer. So the the limit of k into g of x equal to k into m. Next we will discuss the limit x tends to a, f of x equal to whole power k. We know already f of x equal to the limit of k is the any rational number or any constant, and L power k belongs to real number. So f of x whole power k equal to L power k. And next thing, limit x tends to a, f of x whole power g of x equal to limit x tends to a, f of x, and limit x tends to a whole power limit x tends to a, g of x. This is the very important to finding the limits. If we get in these limits, sometimes 0 power 0 and 0 power infinity or infinity power 0, 0 power 0 or 0 power infinity or 0 power infinity power 0. These type of answers we get sometimes. So how we are finding the limit of that two functions, we'll discuss in next video. I introduced the one topic in this video, that is how to finding the L'Hospital rule. What is L'Hospital rule? L'Hospital's rule how to find the L'Hospital rule, how to find the limit when we are using these L'Hospital's rule. First thing, all are remembering, we get the limits 0 by 0 form or indeterminate form. That type of functions we have to use to L'Hospital rule to finding the limit. So let I take the one example, limit x tends to 2, x minus 2 by x square minus 4. First we substitute the x equal to 2, that is 2 minus 2 by 2 square 4 minus 4, that is 0 by 0. We have in this form, this is undefined, that means indeterminate form. Then we are using the L-Hospital rule. That is how we are finding the L-Hospital rule. Let us see. First thing we do the differentiation on separate numerator and denominator separately. First thing I do the differentiation on numerator, that is d by dx. With respect, we have here y, with we do the differentiation with respect to y. We have here x, we do the differentiation with respect to x. We have to here x. So to find the limit, finding the differentiation with respect to x. So x minus 2, differentiation of x with respect to x, that equal to 1. Differentiation with respect to x constant 0. 1 minus 0 is 1. And d by dx of x square minus 4, that is 2x. Now we are finding the limit x tends to 2, 1 by 2x, that equal to, now we are substituting, we are finding the limit that is 1 by 4. I substitute the value of x equal to 2. Why? X approaches to 2. So I substitute the value of x equal to 2. That is, the limit of this function is 1 by 4. And I take the one more example, that is limit x tends to 1, x power 4 minus 1 by x minus 1. That is, now we are finding the limit first. That is, first we are finding the limit, that is 1 minus 1 1 minus 1, that equal 0 by 0. Now we are finding the differentiation of numerator and denominator, that is 4x cube by 1, that is 4. Limit x tends to 1, 4x cube, that is the limit of this function is 4. Let us discuss one more example, that is limit x tends to 0 cos x sin x by x square. That is, limit x tends to 0, cos 0 1, sin 0 0, 0 into 1 0. So x square 0, we have here also 0 by 0, that is undetermined form. We have to use the L-Hospital rule to finding that function of limits. That is, first thing you do the differentiation with respect to x on numerator and denominator. Here we have to you see sin 2x form. The denominator is in the form of sin 2x. When we have to here we have 2, the sin cos x into sin 2 sin x cos x equal to sin 2x. I do one thing, limit x tends to 0, 1 by 2 cos x and sin x by x square. Here limit x tends to 0, 2 sin x cos x means sin 2x. sin 2x by 2x square. Here we get also sin 2x by x square is also the limit of these function is also 0 by 0. So it was undetermined form. Now we are differentiation with respect to x on numerator and denominator. So the differentiation of this numerator is sin 2x that equal to sin 2x 2x sin x. What is the differentiation of sin x is cos x, where we have the theta value is 2x. So we have to do the inner derivative also, that is 2, now we are doing the differentiation denominator, that is 2x square that equal to 4x. Now we have to the limit x tends to 0 2 cos 2x by 2 4x. Here we are cancelling the 2 and 2. Now we are substituting the 0. Limit x tends to 0 cos 2x, that means equal 0, 1 by 0. 1 by 0 is also undetermined form. So again we are doing the L'Hospital rule, that is limit x tends to 0. Now I doing to here limit x tends to 0 cos 2x is sin 2x 2 sin 2x by 4x. 4x, what is the differentiation of 4x? That is 4, that equal to 2 sin 2x 0 by 4, 0 by anything 0. We have these here the limit of this function is 0. Thank you for watching this video. Thank you to all. Subscribe to our channel.